Chapter 1.0. The complete AI journey, we establish the foundation for the entire machine learning and AI primer. Before discussing algorithms, neural networks, model files, inference APIs, or cloud deployment, it is important to understand what we are ultimately trying to build. Many AI courses begin with theory or individual models. Those topics matter, but they are only one part of the larger engineering picture. In real systems, organizations do not benefit from a model sitting inside a notebook on a developer machine. They benefit when data is transformed into a reliable capability that can produce useful predictions, support business workflows, and operate safely in production. That is the journey this course follows. Our running example will be a real estate valuation platform. The platform will estimate the market value of a property based on characteristics such as size, number of rooms, age, location quality, energy rating, and other useful features. The purpose is not to turn the course into real estate training. The purpose is to use a scenario that is easy to understand while we focus on the real subject, how modern AI and machine learning systems are built end-to-end. A house valuation problem is useful because the input and output are immediately clear. The input is structured property information. The output is an estimated market value. That makes it a strong practical example for data preparation, feature engineering, regression models, evaluation, model storage, local inference, APIs, application integration, and later production deployment. The first phase in the journey is foundations. This is where we build the mental model for the course. We need to understand what AI is, how machine learning fits inside AI, how deep learning extends machine learning, and how modern generative AI and large language models relate to more traditional predictive systems. Without this foundation, it becomes too easy to treat every problem as if it requires the newest or largest model, when many production problems are better solved with simpler, more explainable techniques. The next phase is data collection. Every machine learning system begins with data. In our running example, that data might come from property listings, historical sales records, public datasets, real estate databases, or internal business systems. Each source may provide useful information, but each source may also introduce inconsistencies, missing values, duplicated records, or incompatible formats. Before we can build intelligence, we need to understand where the data comes from and whether it is reliable enough to support learning. Once data has been collected, we move into data preparation. This is where tools such as Pandas and Jupyter Notebook become central. Pandas gives us a powerful data frame structure for working with tabular data, while Jupyter gives us an interactive environment where code, results, charts, and observations can live together. In this course, we use these tools to inspect housing data, understand column types, explore distributions, detect missing values, remove duplicates, and prepare a dataset that is suitable for machine learning. After preparation comes feature engineering. Raw data is rarely the best possible representation of a problem. A property dataset may contain size, price, location score, and age, but the model may learn better if we create additional features such as price per square foot, age categories, location quality bands, or interaction features that combine multiple signals. Feature engineering is the practice of helping the model see the patterns hidden inside the data more clearly. The next phase is model training. This is where machine learning begins in the narrow sense. During training, the model looks at historical examples and learns relationships between input features and the target value. In the real estate valuation platform, the target is the property price. The model learns how property characteristics influence value and gradually becomes able to estimate prices for properties it has not seen before. We will begin with classical machine learning using scikit-learn and later move into neural networks and PyTorch. Training alone is not enough, so the next phase is model evaluation. A model that performs well only on the data it has already seen is not useful. We need to test whether it generalizes to new examples. This is where concepts such as train and test splits, validation, regression metrics, classification metrics, overfitting, underfitting, and model comparison become important. Evaluation is the discipline that turns model training from experimentation into engineering. Once a model has been trained and evaluated, it becomes an asset. That leads to model registry and storage. A trained model must be saved, versioned, tracked, and managed. Later in the course, we will explore model artifacts, checkpoints, and safe tensors. Safe tensors is especially relevant in modern AI because it provides a safer and efficient format for storing model weights compared with older serialization approaches. This phase teaches us to treat models as production assets, not temporary files. The next phase is model distribution. Once models exist as managed artifacts, they need to be shared, loaded, reused, and sometimes downloaded from external ecosystems. This is where platforms such as Hugging Face become important. Hugging Face is not just a place to find large language models. It is also an ecosystem for datasets, tokenizers, pipelines, model hubs, and reusable AI components. Understanding distribution helps us move from isolated local experiments toward reusable engineering workflows. After a model is available, we move into inference. Inference is the process of using a trained model to generate predictions from new incoming data. For our platform, this means taking a new property description and returning an estimated market value. Inference has different requirements from training. Training may take time and consume significant resources, but inference usually needs to be fast, reliable, and repeatable. We will first run inference locally before exposing it through an API. Application integration is the phase where the model becomes useful to other systems. Instead of requiring someone to run a notebook manually, we expose prediction capabilities through an application interface. With Fast API, we can build an inference endpoint that accepts property details, loads the trained model, runs the prediction, and returns an estimated value. This is where machine learning becomes a service that software systems can consume. Finally, we arrive at deployment and operations. A production AI solution must be packaged, deployed, monitored, secured, and maintained. Docker helps us package the application consistently. Cloud platforms help us host and scale it. MLOps practices help us track models, monitor behavior, manage versions, and respond when data or business conditions change. This final phase reminds us that successful AI systems do not end at training. They must operate reliably over time. By following this complete journey, we avoid one of the most common mistakes in AI education, treating models as the whole story. A model is important, but it is only one component in a larger system that includes data, engineering, architecture, integration, deployment, and operations. By the end of this course, you will have followed the full path from foundations to production thinking. You will understand how raw data becomes prepared data, how prepared data becomes features, how features become trained models, how trained models become stored artifacts, how artifacts become inference services, and how inference services become real applications. That is the complete AI journey, from data to deployed AI solutions. Thank you for watching this chapter. I hope you found it useful and learned something valuable along the way. If you enjoyed the course, please like, subscribe, and support the channel. It really helps me create more content like this. For additional chapters, complete training paths, and other technology courses, be sure to check out the Opus Magus Academy channel. And if there are specific topics, technologies, certifications, or courses you would like to see covered in the future, please leave a comment below. Thank you for your support, and I'll see you in the next chapter.